Okay, now we are moving towards the last section of the topic, relative velocity, and in this section we will learn the concept of velocity of approach. So let's begin with a problem. The problem says that there is an equilateral triangle ABC. There are three particles at each vertex. The side length of the triangle is of A unit, and the particle A follows particle B always. Particle B follows particle C, and particle C follows particle A. Okay, each of the particle moves with a constant velocity, constant speed of V unit. Okay, now the question is, how much time will it take for the particles to collide with each other? So conceptually, it's a good problem. We should spend some time, at least spend 60 seconds thinking about it. Now the first, intuitively, you can understand that all the three particles are going to collide at the centroid of the triangle with the argument of symmetry. Let's consider the motion of A and C. Let's see what's going to happen. At this very moment, A is going to follow C. Let me draw an enlarged triangle. A is going to follow C. Suppose A covers a certain distance of this much in a certain amount of time, because A is following B and C is going to follow A. So C covers a certain distance and B is going to follow C. So B also covers a certain distance. Although this thing is going to happen continuously, but just for the sake of understanding, I'm taking it step by step. So now what happens is A moves a certain distance. Now this is the line on which the C should be moving, because C was following A. Now A has moved. Now the line of motion of C should be this. C should move on this path to follow A. B has moved, so A should move on this path to follow B. And C also has moved, so B will follow this path to follow C. Similarly, A has moved further, so C will move further. C has moved further, so B will move further. B has moved further, so A will move further. And you know what's going to happen. They're all going to come at the center of the triangle like this. So they are going to collide at the centroid of the triangle. Fine. So they are going to collide, all three of them are going to collide together because it's a symmetrical form. Okay, so having understood that all three are going to collide at the center of the triangle simultaneously, now what we have to find is, we have to find the time that it would take for any one of the particle to reach at the centroid, because when one of the particle reaches, all three of them reaches. So what we are going to do is, we are going to use the concept of velocity of approach here. To understand that, let's consider two particles, A and B. Now A is moving with 5 meters per second and B is moving with 5 meters per second. And the distance between A and B is 10 meters. Tell me how much time is going to take for A and B to come together? 1 second, right? Because the velocity of approach is 10 meters per second. A is approaching B with 5 meters per second and B is approaching A with 5 meters per second. The velocity of approach is 10 meters per second. So they are going to cover the distance of 10 meters in 1 second. Similarly, the velocity of approach of B and C, let's consider. At the initial position, B is moving with a certain velocity and C is moving with certain velocity. This angle is 60 degrees because of the fact that triangle is equilateral triangle. This is V, this is V. Now calculate the velocity of approach of B and C at the very beginning of their journey. The velocity of approach will be the velocity with which B is moving towards C and the velocity with which C is moving towards B. Now B is moving towards C with a velocity of V and C is moving, if you break the component of C, it will be V cos 60 along this line. That is V by 2 and V sin 60 along the perpendicular line, root 3 by 2V. Now this root 3 by 2V has nothing to do with approaching B, because this is perpendicular to the line, and two vectors, if they are perpendicular, they are independent of each other. We had this discussion several times before. Now this perpendicular velocity will not enable C to approach B. The velocity along the line BC will only enable C to approach B. So the velocity of approach in this case is 3V by 2, and this velocity is not helping C to reach towards B. Okay, so velocity of approach is 3V by 2 initially. Now what's going to happen next is C is going to take a turn and B is going to follow C. So the line, the angle with which C is going to turn, B is also going to turn with the same angle. So this angle of the angle between the velocity vector of C and the line joining B and C is 60 degree. That angle is going to remain the same, because if C turns with certain angle, B adjusts itself to follow C, and the velocity vector of C will continue to make angle of 60 degree with the line joining B and C. So velocity of approach will always be 3V by 2. And when they collide at the centroid, the distance is going to be 0. Initial distance is a unit. So actually the time that it will take for C to reach B or to B to reach C will be total distance that it has to cover, that is a unit. And the velocity with which they are approaching each other, that is 3V by 2. So the time that it would take is 2A by 3V. In this given time, they will come together.